All right, this is our first lesson for exam 4, and we're going to start graphing polynomials today. It's really going to be a two-part lesson. I'm going to post part 2 on Wednesday, so break it into 2 shorter parts. So to start off, this is a polynomial. Okay, we're going to graph them. We've done graphing polynomials a lot in Algebra 2, so hopefully you'll remember some of this. But here's an example of a polynomial. I have 3x cubed plus 4x squared minus 2x plus 1. Okay, a polynomial is just a sum, meaning plus, or difference of monomials, or a monomial, okay? And a monomial just means one term. It cannot have negative exponents, and the exponents have to be integers, okay? So like x to the negative second, that would not be a polynomial, okay? In order to be a polynomial, it has to be a positive integer and not negative, and the variables cannot be in the denominator. So if you ever have a term that's like 2 over x, okay, that would not be a polynomial. So this right here is a pretty standard polynomial. You can see it has 4 terms. These will be really important words that you'll need to be able to understand as we go throughout the lesson. So you can see a term is anything separated by a plus or minus sign. So there's 4 terms, okay? Now, the degree, that's one of the most important things that you'll need to know, is the largest exponent. In this case, the degree is 3. Okay, so I just say this is a degree 3 polynomial, which you might remember is called a cubic polynomial, okay? But it's important to be able to identify the degree. The leading coefficient. A coefficient is a number that's multiplied to a variable. So like 4 is a coefficient, negative 2 is a coefficient, okay? 3 is our leading coefficient because when the polynomial is in standard form, that's the coefficient that's in front. And remember, to be in standard form, it has to be ordered from the largest exponent down to the smallest exponent to the constant. Okay, and remember, a constant is just a number that doesn't have a variable attached to it. Okay, so in this case, our leading coefficient is a positive 3. Our degree is 3, and we have 4 terms. Okay. So that's really important to understand because that will help us determine the end behavior of the graph of the polynomial, okay? Polynomials are graphs are nice, smooth curves, okay? There's no points or edges. They're nice, smooth curves. So if you're writing this in your spiral, you can just copy down a quick little xy axis to copy these down. And if you need to pause the video, you can. I'm also going to post your pretest number 4, and there's some similar to this on pretest 4 that you can copy as well. But these red arrows show all of the possibilities of the end behavior of the graph. And by end behavior, I literally mean where do the ends of the graphs go? What direction do they go? So one possibility is the polynomial could start at the bottom, and it could do its thing, and then it could end at the top. Now, we don't know how many bumps and curves and x-intercepts there are yet. We'll learn more about that on Wednesday. A polynomial can have lots and lots and lots of humps, but we don't know yet. But we do know in one scenario it could start at the top and end at the bottom. I said that backwards, bottom to top. The other way, when they are different, is they could start at the top and end at the bottom. Okay, so it could come down, do its thing, and then end going down forever. And the ends of our polynomials always go on forever. Okay, they don't stop. So the domain and range here would be all real numbers. The next scenario, a polynomial could start at the top and it could end at the top, like a W. Okay, a very common one we see is a parabola. A parabola is just an x squared polynomial, and they can start at the top and end at the top, because they're even, or we could have a quadratic that starts at the bottom and ends at the bottom, okay? So it doesn't necessarily have to be a quadratic, but it could have a few humps and then start at the bottom and also end at the bottom, okay? And to figure this out, we're going to use this little table. And once again, if you want to pause and write this down, you can, but this table is actually on your pretest number 4 that I will post to this module. Okay, so if you want to copy it just on your pretest, you can do that. Okay, the end behavior is determined by the leading coefficient and the degree. So pretend like we have ax to the n here. Now pretend like that's the first term in some polynomial. So like plus bx to the n minus 1 plus c. We don't know, it's some big polynomial, but this is the first term, okay? So if I had like 3x squared minus 4x plus 1, I'm only talking about the first term. That's what this represents. And a is the leading coefficient. So a, I'll put, is the leading coefficient, and n is the degree when it's in standard form. And we'll talk more about that in a second. Okay? If the degree is even and the leading coefficient is positive, if the degree is even and the leading coefficient is positive, that means that our polynomial is going to start at the top of the graph and it's going to end at the top of the graph. So if I pull out my handy dandy calculator here, and you can use Desmos to graph if you'd like, but if I graphed so a positive leading coefficient and an even degree, so in this case I just picked a 2. If you graph that, we can see it starts at the top and it ends at the top. We got a parabola there. Okay, I could change that exponent of a 2 to a 4, and it would do the same thing. As long as the degree is even, then it's going to start up and it's going to end up if the leading coefficient is positive. I could change that to a 10. It's going to start at the top and it's going to end at the top. Okay. Now, we can add to our polynomial. Obviously, we can add more terms to this. So let's say I had 6 as my exponent. Plus 5x to the third plus 2x squared, whatever you want. That first term still has a positive 4 leading coefficient and a degree of 6. So no matter what, it's going to start at the top and it's going to end at the top. You can see it did a little bit of extra in there, but it still started at the top and it ended at the top. Now, if you want it to start at the bottom and end at the bottom, all you have to change, let me just clear this out, is the leading coefficient, and it needs to be negative. So if I made that a negative 4x squared, it would now start at the bottom and at the bottom. Okay, but as long as the degree is even, so if I change this to an exponent of 4, it's going to start and end in the same place. Okay, so if I go back to my little chart here, so the degree is still even, but now if you change the number in front, the leading coefficient to negative, it starts at the bottom and ends at the bottom. Okay, now if the degree is odd, the ends are going to start and end in different places. So a really easy one is if I do x, let's say 2, positive 2x to the 3 exponent. So the leading coefficient is 2, it's positive, and the degree is 3. Then this graph is going to start at the bottom and it's going to end at the top. Okay? You could change this degree to a 7 if you wanted. As long as it's odd, it's going to start and end in different places. Start at the bottom and end at the top. And you can mess around in Desmos with this if you want. You could add more terms on. So if I made this like, if I added a term, maybe 2x squared minus 4, I don't know, just making random stuff up here, it's still going to start and end in the same spot. It's going to start at the bottom and end at the top. Just like so. Okay, so if the degree is odd and a is positive, it's going to start at the bottom and end at the top. Positive, I think, up the mountain. We start at the bottom of the mountain, we end at the top of the mountain. But if the leading coefficient is negative, you guessed it, it's going to start at the top and end at the bottom. So if I went back to my graph here and I changed that to a negative 2, that's all I do is if I change the very first leading coefficient to negative, it's going to flip it so it starts at the top and ends at the bottom. Okay, So this is the main concept of end behavior, is knowing where a polynomial is going to start and end. And these are your 4 scenarios. Okay, so I might just write in here, I'll write an example of each. So we said even was top would be a positive coefficient and some even exponent. If we want it to start at the bottom and end at the bottom, then you would just change that leading coefficient to be negative, but the exponent is still even. If you want it to start at the bottom and end at the top, you would want some positive number in front with an odd exponent or degree. And if you want it to start at the top and end at the bottom, remember we just make that leading coefficient negative, but the degree is still odd. Okay? So we're just going to do a few of these examples real quick, and then we'll be done for today. So these are something real quick to point out. These are the same polynomial. One is in standard form and one is in factored form. Okay? Now keep in mind when we're talking about end behavior, we always are talking about it when it's in standard form. Okay? So if it's not in standard form, you don't necessarily have to FOIL it all out, but you could at least think to yourself, how could I figure out the degree and leading coefficient without having to do all that? Obviously, to get from factored form to standard form, we'd technically have to FOIL this all out, and then whatever that came out to be, we'd have to FOIL that, and then you get this big long algebra process to figure out that it's x cubed minus 3x squared minus 4x plus 12. But remember, the only thing we need is the very first term. And the way you can figure that out without having to do all this foiling is just multiply all the x's together. X times x times x is x cubed. Okay? If I had, let's say I'm making this up, if I had 2x plus 1 times 3x minus 4 and times x plus 1, if I wanted to find out the leading term, you'd just multiply all of the x terms together. So 2x times 3x would be 6x squared times another x would be 6x cubed. Now we know that this has a positive leading coefficient and an odd degree. So just keep in mind, when I'm talking about end behavior, I always want standard form, and all we care about is the very first term. So let's do a few practices of these, okay? All I want is the degree, the leading coefficient, and a quick graph of the end behavior, okay? So this very first one, it's kind of hiding, but if you think about it, this is really x plus 1 times x minus 2 times itself, right? That's squared. So if I multiply, because this is factored form, if I multiply all those x terms together, we know that the very first leading term would be 1x cubed. Sorry, that's a cube, 1x cubed. So moral of the story, that is positive. It has an odd degree. That's the word odd. So therefore, positive odd, we would start at the bottom and end at the top. Okay. Number 2 is in standard form. So the hard work is done for you. If it's in standard form, all we care about is the very first term. And I see that it's negative, the leading coefficient is negative, and the degree is odd. So if you want to write it out, that might help you. So negative leading coefficient, the degree is odd. That means we're going to start at the top of the mountain and end at the bottom of the mountain. If you need to resort back to your little table, that's totally okay. Now, number 3 is factored again. So if you multiply these x's together, you would get x squared. But notice, kind of important here, there is a negative in front. So if I were to FOIL this whole thing out, that would be a negative x squared. So I guess it's good to point out that you pay attention to any coefficient that might be out front of factored form. But regardless, this would be a negative x squared polynomial. So the fact that the degree is even and the leading coefficient is negative, a negative even starts at the bottom and ends at the bottom. Remember, even starts and ends in the same spot. And the last one, If you want to write it out, you can. If you can already tell what this is going to be, really that's x minus 5 times x minus 5, which is x, and this is x plus 7 times x plus 7. So ultimately, this is going to be a degree of 4 because there was 4 x's hiding in there. So x times x times x times x, they're all positive x's. There is no negative coefficient or anything, so this would just be a positive x to the 4th polynomial. So positive even would start at the top and end at the top. You should be able to determine these without graphing, okay? You should be able to determine the end behavior without having to use Desmos. There's only 4 scenarios, and all you need is that very first term, okay? So for your questions on Edpuzzle today, I'm going to ask you for each of these, example 1, example 2, and example 3, all I want is the leading coefficient and the degree of each of them. Okay, so submit those at the end of this Edpuzzle, and that's all for part 1. Okay, part 2, like I said, I will send out on Wednesday, so keep an eye on that.